Scott's Geography Notebook.
Do you want to try saying it?
Da, da, da.
I could go through and show you all of the numbers and all of the percentages and everything else like that of where the water is. But what I want to do in this presentation is talk a little bit about the amount of water that we have on Earth and the somewhat scarcity of the water that we have. So our Earth in many ways, especially in our hydrologic cycle, is a closed system, meaning that from space we don't really get that much water coming in and we don't really lose all that much water going out. And so if we were to take all of the water on the world and narrow it down to 1 gallon, I want to talk a little bit about what each, where that water actually is. Right, now, between you and me, there's actually a little bit of water. Okay? We have in our atmosphere a lot of water vapor. We do have droplets that form. Those are going to be our clouds and our fog and other things like that. We see that water fall from the ground, but the amount of water that is in the atmosphere compared to all of the water on the Earth, it's minuscule. It's actually it's 0.001%. Okay, so if we think about a percent, that's 1 out of 100, and this is 0.001%. If we were to think about the whole gallon, 1 drop is all that there is in the atmosphere. Okay, and it almost ran away from us. We don't want that. There we go. 1 drop in the atmosphere. Okay, now there's water other places. One thing that's really important is water for our trees and our plants and everything else like that. That's going to be our water that's in the soil. So I call this the subsurface in some of my presentations. It isn't on the surface necessarily, but it is in that topmost layer of soil, and that's what the plants are able to access. Again, if we think about all of the water on our planet, 0.005%. Thank goodness that 1 drop is 0.001, right? So 1, 2, 3, 4, 5 drops of water is all of the water out of everything on Earth that's in our soil. Okay. Now, there are on our planet a number of lakes and oceans and streams and all of that. That water is really, really important. One drawback, though, is that a lot of that water that we have in our oceans and our creeks and everything, some of it is salty. Okay, some lakes, for example, the Salton Sea in Southern California, Mono Lake, Eastern Sierras in California, the Red Sea, the Dead Sea, a lot of other large bodies of water are saline. They have a higher salt concentration. Okay? Well, those lakes are there. They do count for some of the water. If we were to, again, go with our whole gallon of water, that's going to be 6 drops of water. I think I'm doing an extra drop on each one of these, but that'll be okay. Okay, our 6 drops of water for those saline lakes. What we're really excited about is going to be our fresh water, our lakes and streams, the Sacramento River, the San Joaquin River, the water that we send down the California Aqueduct and that goes to the LA Aqueduct. All of that's going to be our fresh lakes and rivers. That accounts for 7 drops. 7 drops of all of the water on our planet are in those fresh lakes and water. Okay? Well, good. Well, let's go to our next one. Groundwater. There's going to be 2 different places where we're storing groundwater. There's going to be groundwater that's going to be somewhere between 20, 30, all the way down to maybe a couple of 100 feet down below the surface. And that water is usually what we use when we're going to be putting in a well and we're going to be pulling up that water. Municipal water, city water, a lot of times they will have their own wells. A lot of people that live in the country have their own wells. A lot of agricultural land is going to be using wells as well. And how much of the water on all of the planet is down there in the groundwater? It's going to be about a tablespoon. So I'm going to try to do this and not lose any of my water. Oh dear. 1 tablespoon of our water accounts for all of the groundwater. Right? That's the water that is going to be in the ground that's more accessible to us. There's other water that's down there, but that other water is much, much deeper. That water that is in what we call the deep groundwater. And that's going to be like hundreds to thousands of feet down below the surface. That water is really hard to get to. It's expensive and difficult to drill down to, and it is expensive to pump up out of the ground. When you have a well that's 30, 40, 50, 60 feet down, it's pretty inexpensive to pump that water up. When you're going down 1,000 feet, it really isn't worth it. Out of all of the water that we have on our planet, or at least down deep below our planet, still another tablespoon is for that deep water. Now there's another resource that's really valuable, it's important to us, and that's going to be our ice and glaciers. Now when I say that it's important, it isn't necessarily that it's accessible water, okay? But those ice and glaciers are really important to kind of keep the water where they are. We really don't want to see them dissolving. Out of all of the ice and glaciers, counting Antarctica, counting Greenland, counting all of our montane glaciers that we have around the world, that's going to account for about a half a cup of water out of our full gallon. And so 1/2 cup for ice and glaciers. Okay, the rest of the water that we have on our planet is here as oceans. 97% of the water that's on our planet is made up out of oceans. Right? It's all salty, right? So what do we actually have that we use, right? So thinking about all of the water that comes to the pipes in our houses, all of the water that we use for our municipal uses, the water that we use to grow our food, the water that we use to raise animals, all of that water comes from two main places. First, we have our fresh water, our lakes and our rivers, and we're going to have our groundwater. Out of all of the water that's on our world, that's basically the water that we're able to get to.